So what you're going to need here is you should have a big bag with some little bags and a vial in there and a cup. So hopefully you've got that. I think a few people still joining into these rooms. Hope it goes smoothly. All right. So if you can, you've got a cup here. You can go get some water, fill it up. So give you a second there. Fill up that cup with some water. If you're just joining us, you should have a big bag with two little bags in it with some powder and a vial and a cup. Go fill up the water with some cup, or fill up the cup with some water. A little bit better. All right, so we're gonna give this a try. So there should be one bag in here with kind of a grainy, bally white thing, white little balls, okay? White one. Oh, you can see that, okay? And so what I want you to do is, I'll show you, add a little bit of water, just add enough water to kind of coat everything, about this much, and then start mixing it up, okay? If you add too much water, that'll be okay. Just take a little bit longer. Start mixing it up. Ooh. Okay. Do you feel anything happening? You can unmute if you need to. Feel anything happen? Feel it getting hot? Should be getting warm, okay? So this is what we're working with here is something called rock salt. It's calcium chloride, okay? So the calcium chloride is the same stuff that you'll throw down on ice to melt it. So on Wednesday, we're supposed to get some ice and some snow. And so your parents might throw that onto that in order to melt it. And it does that by when it dissolves, it gets pretty hot. So it heats up and melts the ice. I don't know about you, but this is getting kind of hot for me. Okay. So that's rock salt. That's an example of a reaction that gives off heat as it goes. Okay. So I should have mentioned, I'm a chemist at University of Iowa. I teach chemistry to a lot of the undergraduates. And so these are some of the things we learn about. If we take the other bag, it's got this fine powder in it, okay? And that's actually just, here we go, baking soda. So you can get that at Hy-Vee. And I want to do the same thing, just add a little bit of water to it. Here we go. And then mix it up. This will feel a little bit nicer. And then you're mixing it up. If mixing up, it's cold. This one should feel cold. And so this is an example of reaction when the chemicals are reacting, it's actually taking heat in. And so it's making it cold. And now what we can do is something also very fun. We have a bigger Ziploc bag. And so just add in, pour both of the liquids in there and then close it up. So I'm going to pour in both of them, the hot and the cold, and then close it up, seal it up quickly as you can. There we go. So this, there you go. You should see it fizzing. It's an example of a very fast reaction, and it's called an acid-base reaction, and it's giving off carbon dioxide. That's what the baking soda does. It likes to give off carbon dioxide. And so it's going to fill up this bag with carbon dioxide. If you have it sealed, you can, we'll just put it off to the side and it'll slowly start filling up with the carbon dioxide. Sometimes I actually fill up the little bags, but those tend to burst. All right, so I'm going to just put that off to the side. So those are examples of some reactions that we do that as chemists all the time, acid-base reactions and stuff that give off carbon dioxide. Now what we need is, we still need, you should still have that water in there. You can go fill it up if you want. I'm going to fill it up, or if you still have enough water in there, that should be okay. And now you've got here we go. You should have this little vial, okay? This vial is full of a special salt, okay? So this salt, you know, what happens when I add table salt to water? What happens to that? I make salty water, right? It dissolves. Okay, try it. I mean, add some salt into water. You'll see it dissolve, and if you drink it, it'll taste like salty water. Similar to the same thing if you go down to the ocean, which is a long ways from Iowa, and drink some of the water, it's a little bit salty. This is also salty, but it's a special type of salt. Okay, so what I'm going to do is I'm going to add it to this cup, and the cup of water. You may need to tap it down with your finger if it stays stuck on the top. And then just wait. You should have a clear glass so you can see, look at it from the side. That's what I always encourage people to do. Look at it from the side. You can see something happening. Oh, I can't pour the water out. It's it's a solid. Okay. Yeah, it's safe. I mean, don't drink it. Don't eat it. But other than that, it's pretty safe. You can touch it. It's not that the water frozen. It's just that this is a special type of salt. It's actually made out of plastic. And so this salt just takes water, absorbs it, and then it swells. And it does that very quickly. Because it's a salt, it really loves water. Salts just love water so much. That's why when you add table salt to water, it dissolves. But this can't dissolve. It's a very special type. And so what it does is just swells and absorbs the water. It's the same thing that we add to diapers, because we got to absorb liquids pretty quickly. And so a little bit of this goes a long ways towards absorbing what babies can give off, what babies do a very good job of producing, okay? They also take this stuff, and I can buy a big thing of it. This would absorb a whole lot of water. If I throw this into a pool, I'm going to create a lot of problems. But sometimes people out west, they buy this, they throw it on their house and then they spray it and it absorbs all this water. Because then if they do this before a forest fire is coming into town. So that way it might help protect their house from being burned down. Okay. So you can feel it. It's kind of a fun thing to play with. My kids love doing this. Yeah. Now I've also got some, where's that? I have some liquid nitrogen here. Pour it. So this is liquid nitrogen. It's very cold. So nitrogen is most of what you're breathing. What you breathe is about 80% nitrogen gas. Okay. This is just that nitrogen gas turned into a liquid. Okay. And so it's very cold. It's like -200-300 degrees. So if it ever gets this cold in Iowa, we're not going to have class. Okay. But it's very, very cold. Now, I have a balloon here. Now, what happens to liquids when they evaporate and turn into gases? Like, let's say you start boiling something. Can you smell that somewhere else? Yeah, you can smell it somewhere else. Or if you're like me and you've put something in the oven and you forget about it and it starts to burn, that smoke goes everywhere, right? So when we go from something that's a liquid to a gas, the gas expands out and goes everywhere, okay? And so what I want to do here is I've got a balloon and a spoon. Now, how many spoonfuls of this liquid nitrogen should I put in the balloon? Should I put 1 or 2 in there? 2? All right, so watch this. I'll put 2 in there and then I'll seal it up. And again, this spoon is not very big. Yeah. So I'm just going to put 2 spoonfuls of liquid nitrogen in there. And then, oops, it broke. Let me do that again. My balloon broke. So I take a different balloon. I got 1, 2. There we go. There we go. So what's happening right now is the liquid nitrogen's warming up from like 200 degrees below zero and turning into a gas. As it's a gas, it expands. And so it's blowing up the balloon. It's blowing up the balloon. Now, what I can do, I'll put this down by the side. I'm going to do one more. Now, what happens if, so I only added 2 spoonfuls of liquid nitrogen. What happens if I add in 4 spoonfuls? You think it's going to blow up more or less? In 4, oops, here we go. 4 spoonfuls. So we could do the experiment. This is with 2, and then I'll add 4. 1, 2, 3, 4. And try and get it closed off. So same thing, it's expanding out because that liquid nitrogen is evaporating and becoming a gas. And as it's doing that, it's expanding out the balloon. Okay. And it's getting kind of cold on my fingers. And so we can compare. The one in red, I added 2 spoonfuls, and the one in green, I added 4. So you can just see how much more it expanded out because of that. Okay, because I added more of the liquid nitrogen that became a gas. Okay, so it's very, very cold. Oh, you might want to look at this. Hopefully it hasn't blown up. You should be able to feel that it expanded quite a bit. There's a lot of carbon dioxide in there. The fizzing should probably be mostly over. If you had it sealed up, you'll see that it's expanded out. Now here's something else I can do with this liquid nitrogen. Over here, I have a balloon. Okay. Now I just blew up this balloon. I just used air, not a problem. Here's a question. Do you think I can fit this balloon inside the cup of liquid nitrogen? Well, let's skip the experiment. So the liquid nitrogen it's very cold. It's about -200-300 degrees. And most of what you're breathing right now is nitrogen. And so what I can do is I can take all the air in here and condense it into a liquid. So watch this. I could get the whole balloon inside the cup. Okay, because I took all that air in there and turned it into a liquid. So now I could take it out. And as it's warming up, it's expanding out. Oops. It's expanding out into a gas again. Expanding into a gas and blowing up the balloon. So you can blow up the balloon with that liquid nitrogen, turning it from a liquid to a gas and gas to liquid. And that's what we call phase transitions. We talk to our, when I teach my courses, I talk about these things happening, going from a liquid to a gas and a gas to a liquid or a liquid to a solid, okay? And so, for instance, what we can also do, oh, here we go. So it's kind of warm out, but it's been cold, right? Been cold recently. And so when you go outside when it's cold out and you first step outside, I like to go breathe out like that so I can see my breath, okay? And I can see my breath because it's cold outside. And so all the water vapor coming out of my mouth starts to freeze. And that's what you're looking at, okay? And so I can kind of mimic that with this. This is just a cheese ball, okay? And I'm going to stick it into the liquid nitrogen. And this is hard to see, but it's actually boiling the liquid nitrogen. It's kind of weird, but the liquid nitrogen boils at -200 or so. And so when I put something that's room temperature in there, it's very hot and it starts to boil. So I can freeze it and I can put it in my mouth. And it's just like stepping outside. So I can breathe. It's called fire's breath, dragon's breath, but it's the same idea as when you go outside when it's very cold. Excuse me. You just, your breath is freezing when it hits the cold air and you see the water vapor, okay? Excuse me, that was a little bit hard. Now, what we also have, I just want to do one more thing with this. Oh, one more thing. I bought some flowers last night and my wife thought they were for her. And so I probably have to go buy her some flowers today, but they're not for her. They're for science. Okay. I bought these from Hy-Vee. Okay. You can see this. And it's just a nice soft flower. Okay. Now what happens to water? When water freezes, it becomes ice, right? And ice is something that you can break. It's a solid. You can take a icicle and then you can break it. You can't really break water. Water's a liquid. That's not the same thing. The same, but it's like this too. This is a flour. It's very soft, okay? If I freeze it into a hard solid, I can break it, okay? So what I'll do, and I wish it was clear, but I'll put it in here, and you can see it boiling. Hope you can see that a little bit. It boils because this is liquid nitrogen, so it boils at minus 200 degrees. So I can freeze the flour. And then what I can do is take it out. It's steaming. Still looks the same, but I can break it up into little pieces, okay? Just little pieces. Because it got frozen solid, okay? So it freezes very quickly, and then that becomes breakable. This is a little bit easier to see, maybe. Here's a glove, okay, that you might get at a doctor's office, okay? A little bit too small for me to put on. It's a glove, and so it's stretchy, okay? So it's the same idea. When water gets cold, it freezes to ice, and ice you can break, okay? And then when ice warms up, it becomes water again. So the same thing will happen with this. When I take it and freeze it, I put it in there to liquid nitrogen, it freezes. And then when I take it out, it's going to be frozen solid. It'll be a hard, it won't be rubbery anymore. And so I can break it into little pieces, okay? Here's a little piece. But same thing with water. When ice warms up, it becomes water again. And when this warms up, it goes from being brittle back to being soft, okay? It's a concept about phase transitions where we can go from something that's a solid to a liquid or from a liquid to a gas. The same thing happens for hard polymers like this, these plastics. They can go from something that's very soft and rubbery to something that's very hard and brittle that we can break, okay? Now, where do I have that? Let me take this, pour some water in here. Here we go. So I just have a cup of water. And what I want to do is I want to add some, here we go, some vegetable oil. What happens with vegetable oil and water? What happens if I mix these two together? I'm going to separate, okay? See that? So I pour some in there. Right. As they separated, you can see the oil layer on top. And what's nice about this is I can mix it up, make it very turbid. You can try this a little bit later. Mix it up very turbid, but then it still goes up and separates. The hexane, or sorry, the oil, the reason why it floats on top of the water is it's less dense. And so it weighs a little bit less per unit volume, okay? Weighs a little bit less. And so when we have an oil leak in the ocean or elsewhere, when we're drilling for oil, it leaks out, oil tends to go up to the surface, okay? Now, what I have here, there we go, is a little bit of food dye. I got this from Hy-Vee last night, okay? And so the food dye, this is something we add to make colorful frosting and such, okay? This is a nice green one. And what we can do is we can add it in here, but this is a water-based food dye. And so I add it to the oil. It just sits on top, okay? It sits on top, but when it hits to the water, it starts dissolving, okay? Because the the food dye is based on a water product. So it loves water, but it doesn't love the vegetable oil. So certain things dissolve in certain other things, okay? So we're worried about, oh, there we go. It's very nice. It dissolves very well. Okay? So what you can do is you can try this at home. You can even add other colors. You could get a very colorful arrangement as the dyes dissolve into the water. It's really can be quite nice. What we also have is, oh, here we go. What happens, let's say it's Saturday and you're playing around a lot and you're running around and then you stay up really late and you get tired. You don't have any energy, okay? When you're very tired, you don't have energy. What do you like to do? You just like to sit around and not do much, right? I don't know about you, but when I get very tired, I don't want to get up and go biking for 10 miles or something. I just want to lay around, okay? It's the same idea with chemicals, okay? So I just took, this has been in ice, okay? So it's been very cold. And if I add a little bit of food dye to it, the food dye should dissolve, but watch this. Okay, here we go. See how slow that is to dissolve? The food dye it's slowly dissolving and mixing with the water, but it's very slow because the water is very cold. This has just been in ice. So it's cold water, so it doesn't have a lot of energy. In order to mix the food dye, it needs to have energy. So what I can do is I can take and warm up some water. So I have something I warm up water with right behind me. So when I warm up water, it's just like after you've got a good night's rest, you have a lot of energy, okay? Or when you go over to your friend's house and you go over to a birthday party, you'll have a lot of energy. And so, oh, my water gets, when the water gets hot, it's got a lot of energy. And so it's able to mix the dye up very quickly. We're about to lose the breakout room, but well, it's gonna take too long, so sorry for that. But yeah, if you take this, I don't know if you guys can see this, but mine's got a fair amount of carbon dioxide in there. Okay. Often what we do with baking soda, it's added in there because it gives off that carbon dioxide gas, which makes our food fluffier. So you actually add it into foods when you want to become fluffier, like bread and such. But that's not going to get done in time. Have a good one.